So today I want to talk about the story of a function. We've been learning a lot about functions in the mathematical sense. For each output, there is exactly one input. That is the definition of a function. We can use an input-output table to represent this function. We'd say that you start with an input, you apply a rule, and then you get one output, a single output. We could represent inputs and outputs with tables of ordered pairs, where our X would be our input, and our Y would be our output. We could even take it a step further and say that our X is our independent variable, and our Y, our output, is our dependent variable. And when we graph that, we can see that it results in this nice line. Our x-axis, our independent variable, our y-axis is our dependent variable. All of this describes a function. We can use a graph, we can use a table, an input-output table to describe a function. But it's bigger than that. We're telling a story about two things. And when I think about stories, there's elements of characters, there's action, there's rising actions, climaxes, falling actions, there's relationships and drama. And all of these things tell a story, often between two people. So when we think about functions, we want to think about the story that's happening, and specifically the word relationship comes to mind. What is the relationship between the output and the input? Here, how does our Y relate to our X? How does our output depend on our input? How does an input following a specific rule result in a single output? What's the story? How does it change over time? When our independent variable is here, how did that affect the output? Where's the output at? So we can tell this function, we can describe it and show it table, graph. We can also use specific language to tell a bigger story of what's going on, the relationship between our inputs and outputs. So how do we tell this story? So a reminder that our output, the output, is related to the input by a rule, by some rule. Our output is related to our input by some rule. It follows some rule. Another way to look at this is that the the output, or our Y value, or our dependent variable, depends on the input, the X value, or the independent variable. So this language is helping us tell a story about the relationship between these two things. We could also take it a step further, and we could say that our Y, which is our output and our dependent variable, our Y is a function of X, the input, independent variable. So this language right here, the output is related to the input by a rule. The dependent variable, the Y, depends on the X, the independent input. Our Y is a function of X. This is a story of a relationship between two variables. So we represent that with input tables with ordered pairs and graphs, but we can also describe what's happening by specifically spelling out the relationship. So let's look at an example here. There's a story hear about a boy and his bike. Noah is our character. He starts at his house, then he gets on his bike and he rides to his friend's house, stays there for a while, then he comes home, and he's like, I'm gonna ride to the park. Then he rides out to the park, and then he immediately turns around and goes, oh, I'm gonna be late. I gotta go home. So there's a story that's happening here, but we can represent this story as a function and mathematically, but just keep in mind that it's a story, right? So let's take this story and let's translate it into a graph. So if I'm gonna graph out this story, I'm gonna think about the different actions, the different parts. Well, first it says that Noah starts off at the house. So perhaps if I draw like a rough graph, he starts, let's just say here, he's at home. Then it says he goes to his friend's house. So he rides out to his friend's house. He stays there for a while. He stays there for a while. And then he rides back to his house. Then he turns around and says, you know what? I'm going to go ahead and go to the park. Maybe the park's a little bit further out. Then he realizes, oh no, I got to get home. It's dinner time. And he comes straight back to his house. So my graph could look something like this. I took my story and I've created a rough sketch of what my graph could look like. So let's maybe apply this to a coordinate plane. So here we said Noah starts off at his house. We'll say at 0, 0, the origin. And this is time. So I'm going to label this actually time, and maybe the hour. This is the time after noon. So the hour after noon. So this is 1 hour afternoon. This is 1 p.m., 2 p.m., 3 p.m. This is our x-axis. And here I'm going to label this our y-axis. And this might just be the distance from his house, because we're thinking about Noah traveling away from his home to different places. So his house is here, the starting point, and this is how far away he might go away from his house. So he starts off at the origin here. And then we say, okay, let's say it takes him an hour. From 12 to 1, he rides to his friend's house. His friend's house is 4 miles away. Takes him an hour to get there. So at 1 p.m., he's 4 miles away from his house. Then let's say he stays with his buddy until about 4 p.m. And then he goes, oh, well, I'm going to go home now. My friend, we don't have time together. So it takes me about an hour to get home. So I'm going to go ride all the way home. So basically, he starts off at noon, rides to his friend's house, and he ends up right back where he started around 5 p.m. And then we said, oh, I'm going to ride to the park. The park is further out. It's going to take me maybe, let's say, an hour and a half to get there. So at 6:30, he is about, let's say, 6 miles away. And then, oh no, it's supper time. I got to get home. It's going to take me so long to get home. I'm dead. I'm a dead man. It takes him an hour and a half to get home. He's not home till 8. Mom and dad are very upset with him. So if I connect my dots, I've created a graph to represent this story. Looks something like that, just like we sketched. So number 2 asks us to find the quantities and label the axes. Well, we did that. Our 2 quantities that we're looking at are time, specifically afternoon, the hour afternoon. So 1 p.m., 2 p.m., 3 p.m., how many hours afternoon? And then the other quantity that we're talking about, the relationship between them, is his distance from his house. So at a particular time, how far away is he from his house? So then it asks, which quantity is a function of the other? So we go back to our language for telling the story of a function. So again, we know that the input following a rule gives us an output. The time following some rule is going to give us our distance from the house. So we could also say, well, then the dependent variable is the distance. So the distance from the house depends on the time of day. Oh, that means also too that the y, the distance from the house, is a function of the time of day. So using that language to tell the relationship between time of day and distance, we would say the distance from his house, the distance from Noah's house is a function of the x value, or the time of day, time afternoon. So then one more question to challenge us, number 4. Based on your graph, is his friend's house or the park closer to Noah's house? Well, we decided that if we look at our graph here, we said that this is his friend's house, right? He's at his friend's house here. And here he's at the park. So if I look at my y-axis, he's 4 miles from his house. It takes 4 miles to get to his friend's house, but it takes him 6 miles to get to the park. So the answer to number 4 is that based on our story and our graph, the park is further away. So to recap, functions, outputs, and inputs are all about relationships. How do they relate to one another, and how can we describe that relationship through a story? Well, we could say that, again, that our output relates to our input by a rule. The output or the dependent variable depends on the input or the independent variable. And then our y value is a function of x.